This is going to be a long one, too. It's going to be fun and long. The derivative. Come back with me to a time and place where Mrs. Seta showed you a curved line and asked you to find the slope of the secant line. That means you would find 2 points. Let's call this point A. Let's call this point B. Okay. And this point right here, we're going to call it A, comma, F of A. Whereas this point right here, we're going to call it what? B, comma, F of B. Okay, that's what it is. And if I said to you, okay, precious lambs, find the slope of that secant line for me, you would do what you've remembered how to do since Algebra 1, which is y2 minus y1 over x2 minus x1. Or with my notation, you would say what? F of B minus F of A over B minus A. Now, we did this in pre-calculus last year. We called this the average rate of change. Okay? Now, I'm just going to switch up one of these for you, one of these points. I'm still going to have that same curve. I'm going to call, move this down. There we go. Okay. I'm going to call this A still. But this one, I'm going to give a particular distance. I'm going to add H to it. So I'm going to say, all right, let me call this A plus H. Let me add an H amount to it. So then if I asked you to find the slope of the secant line, again, this would be A, comma, F of A. This one, however, would be A plus H, comma, F of A plus H. Are you in agreement with me so far? All I've done is just added H to the A factor, okay? Now if I said, okay, find the slope of the secant line for me on this one, just changing up the letter B and now calling it A plus H, a certain amount of unit, you'd be like, okay, F of A plus H, right? Minus F of A over A plus H minus A, which is, oh, so I have F of A plus H minus F of A over H. Have you seen that before? We did this last chapter. This is called the difference quotient. Now, what the great mathematicians were trying to do was, instead of finding the slope of the secant, okay, I want to make that H value get closer and closer and closer to being near A, as close as I can to A. I want the values of H to get closer and closer to 0. Meaning, again, this is all introduction. Aren't you excited? Sorry. I want, if this is A and then this was your A plus H, and if I found the secant line here, but then I moved it closer to here, this would be A plus H1, and I made a secant line, and then I moved it closer and closer and closer and closer. As the values of H get closer to 0, H1, this could be A plus H2, get closer and closer and closer and closer, what's going to happen to my secant line? What's it going to eventually become or turn into? It's going to, would you agree, become the tangent line? What's this process called when things get closer to 0, as they approach 0? Limits. the limit. So what happens is this secant line that I originally had from these 2 points over here, and then I made another 2 points, and I got closer and I got closer and I got closer, meaning I took the limit as h approaches 0 of this difference quotient. Okay? That secant line, the slope of the secant line, as I took the limit, became the slope of the tangent line at that point, A. This is huge. Why is this huge? Because if I'm talking about my good, let's see, I was thinking Daniel ran track. Anybody here runs track? No one in here runs track. Oh, you did? Okay. If I was trying to find your speed and I said, okay, I can obviously find your average speed at from 1 second to 5 seconds. Okay, your average speed, yeah, I'll just take the slope, the rate of change. But if I said, no, I want your average, I want your instantaneous rate of change at 3.1. That is difficult to find. Because in order to find slope, don't you need a y2 minus a y1 over an x2 minus an x1? So that's what I'm saying. This is very difficult to find at that point. But the process of taking limits changes that up for me. That's huge. Because the secant line can become the tangent line in the process of taking limits, which you just spent all of last chapter on. So, happy introduction. I can see you're all like, this is amazing. I love this so much.
Well, it only gets harder.
So let me give you a definition here.
Oh, yeah.
Okay? The tangent line to f of x at the point A is the line passing through A comma f of A having a slope of the following. The tangent line is equal to what we just wrote up above there before. The limit as h approaches 0 of f of a plus h minus f of a over h. Yeah, I will stop this a minute, provided the limit exists, and then I'll explain. Sorry. The tangent line to f of x at the point A, at that instantaneous point right there, is the line that passes through A f of A. That's what a tangent line means. You're not going through 2, you're going through 1. You're touching it. I can find the slope now as long as I take the limit of that difference quotient. Huge news, y'all. Huge. That's what Newton and Leibniz were doing for years. Okay? Provided the limit exists. Obviously, we looked at in the last chapter when it doesn't exist, right? We've looked at those times. When doesn't the limit exist? Things like that. Okay, so we're gonna come into play with this. All right. So let me do an example real quick. Example 1. Find the slope of the graph of f of x equals x squared at the point -2, 4. Okay, you've never done one like this before because you've always had 2 points. I had 2 points, and then I just took the average of them. And now I specifically want you to tell me what the slope is at that point right there. What is it? Right, I don't know because I've always had 2 points. This is the problem. Okay? So according to this definition, a tangent line to f of x at A is a line passing through having this slope. Okay, so let's use this. Okay? So what do I need to find? I need to find an f of A plus h. Would you agree? I need to find an f of A, subtract them and put it over h and take the limit. Okay? So first thing I'm going to do, f of A plus h. So what does that mean again? What do I do with A plus h? I what do I do with the a plus h? Plug it in, right? If this was f of 3, you'd plug in 3. If this was f of 5, you plug, well, if it's a plus h, guess what you plug in? A plus h. So a plus h squared. Okay? Foil this. You don't know how to foil, you need to get fast at it. This is a plus h. Now the definition says, okay, minus the f of a. What does that mean? What would f of a be? A squared. Okay? So, define the slope of the graph having a slope of this. The slope is defined to be the tangent slope is the limit as h approaches 0 of f of a plus h minus f of a over h. Plug in these two things. So let's see. Limit as h minus 0 is, what am I going to put in right here? What am I going to replace that with?
A squared was 2a plus h.
Yep. Minus, what am I going to put right here? A squared. Stick it over h. Okay? Things cancel. Take the limit as h approaches 0. I can also take out an h, can I? So what do I have now? 2a plus h. Would you agree? Okay. When you get to this point, this is what a lot of the kids in the other class were asking me. They're like, okay, so what do I do now? Well, now you take the limit. What was the first rule of limits last chapter? Plug it in, plug it in. So this doesn't have an h. So this is really a constant right here. This is 2a. So if I don't plug an h in here, but I can plug an h in here, so this would go to 0, agreed? So I would actually end up with 2a. This right here, you're going to want to write this part down, is a formula to find slope.
Can I ask you that last page?
If I take the limit as h goes to 0, this would go to 0, right?
Yep.
Okay. This right here is a formula to find slope. So how do I find the slope at this point? What's my a?
-2.
How do you know negative 2 is my a? A. That's my a. So what would be the slope? 2 times negative 2, which is negative 4. That is the slope of the tangent line at the point negative 2, 4. If I were to graph this for you, because I think it's good to see it visually,
The tangent line's the one that crosses or
goes through one point.
goes through the-
Mm-hmm. So here's your good old parabola, right? You've all seen that guy before, okay? If I said, put a dot at negative 2, 4 right here, and I said, go ahead, draw the tangent line right there. You'd be like, I mean, draw it so that it just touches right at that point. I'd probably go like that, right? But I mean, I might be off slightly. Well, now I'm not off. Now I know exactly what it is. It's negative 4. At that point right there, the slope is negative 4. Okay? Now, what does this mean? What's the big la-di-do? What you just found, this process of deriving a formula, let me just say that again. This process of deriving a formula is called derivative.
We just did a derivative.
Drop the mic.
We're done, guys.
We're done. The process,
How long is
Don't get excited.
I know, don't get excited,
How long?
of deriving, write this down, I'll answer you in 1 minute, is called derivative. What? Stop. By the way, at this point, I want to give you my one and only joke that I can only say a year. Please, please don't drink and derive.
Oh, like your derivative. So like driving.
Right, right. You just did. a derivative. You just did a derivative. The long way, but you did it. And you got to do it the long way the first time. Okay? But now, now here's the thing. I don't really like using A's because honestly, have we used A's really ever? What do we always use instead of A? We use X's. Okay, so I'm going to give you the definition for a derivative with the X's, which our book has. So, definition of a derivative. Derivative. Wow, I didn't know how to spell there for a second. Okay, so the derivative of f at x is given by f prime of x. That is the new notation for derivative. When you see function notation with a prime mark next to the f, that is the notation for derivative. Get used to seeing that. I'm actually going to show you a couple more notations in a moment. But the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, some books will have change of x replaced inside of the h. I just like the h by itself. Provided the limit exists. You need to write that down too. We'll talk tomorrow about sometimes when you can't take a derivative. Okay. And added on to this, I just want you to write a couple of new words because these words can actually come up. It'll say a function is differentiable. Differentiable at x if its derivative exists. So when you see the word differentiable, it also means derivative, process of taking a derivative. Okay. Actually, the process of taking a derivative is called differentiation. The process of finding derivatives is called differentiation. There we go. Okay. You just found derivative. I'm going to make it even a little bit more easier for you. Can you read that, Jack? I'm sorry. I'm going to pull this up more.
Yeah.
So here's what I want you to get in your head. When I say derivative, you say slope. Derivative.
Slope.
Derivative.
Slope.
When I say slope, you say derivative. Slope.
Derivative.
Slope.
Derivative.
Slope.
Derivative.
Derivative.
Slope.
Slope.
Derivative.
Derivative.
Oh, you mean slope.
The derivative and the slope are related together. The derivative is the slope of the tangent line. If tonight's homework says, find the slope of the tangent line, you are going to take a derivative. If tonight's homework says, find the derivative, you're doing slope. Are you with me? Slope, derivative, derivative, slope. Do you have this in your head? No?
The derivative at like -2 and -1.999 is different than -2.
Yeah, I'm worried.
Well, it could be. All right. Some notations.
I don't know.
F prime of x means derivative. Y prime means take a derivative. By the way, this means only first derivatives. There are such things as second derivatives, third derivatives, fourth derivatives. Just wait. It gets funner. dy dx is also an expression or a notation, for derivative. And d dx of the function f of x. Okay? These are all, when you see these tonight, these are asking for derivatives. So, the first example I just gave to you, listen to me. I don't want you to do it with A's. I want you to do it with X's and H's. It's just better that way.
What's the little apostrophe for?
To say that I'm taking a derivative, that I'm finding the slope formula for it. Okay? All right, so we're going to do just 2 examples, and one of your examples will be what are your homework problems tonight, which I am grading.
Good.
Okay. And then we're done. Yeah, well, you can say it's in my notes. Yeah. Okay. All right. So, example 2. Find the slope. You mean what? Thank you so much. Of f of x equal to negative 1/2 x squared. And write an equation for the tangent line at the point 2, negative 2. Okay. Find the slope, derivative of f of x equals negative 1/2 x squared and write an equation for the tangent line at the point 2, negative 2. Okay, so again, I don't want to use the a's. I was just showing you because that's how the process becomes a derivative by taking that secant line. So I am actually going to just find the f of x plus h. So again, what do I do with x plus h? I plug it in, plug it in. Okay, so I would have negative 1/2 times x plus h squared. Would you all agree you just plug the x plus h right there? Okay. FOIL this out would be negative 1/2 times x squared plus 2xh plus h squared. Distribute the negative 1/2. Negative 1/2 x squared. This would be minus xh minus 1/2 h squared. This right here is your f of x plus h. This is what you'll be doing on almost every single problem tonight except for like the beginning. But you're going to have to find the f of x plus h. Okay? You already know what the f of x is. That's up here. Would you agree? Okay? So now you're going to use this formula right here. Take the limit, which is the derivative, which is also the slope. Take the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so the slope of the tangent line is equal to the limit as h approaches 0 of, we just found the f of x plus h, negative 1/2 x squared minus xh minus 1/2 h squared. Okay. Then I'm going to subtract what?
Negative 1/2.
So then it would become positive 1/2 x squared, excuse me. And then I'm going to stick it all over what? H, okay? Before you do any plugging in, plug it in, cancel, clean up. Clean this up as much as you can. Clean, clean, clean. Okay? So clean this all up for me. Let's see. These go away. Agreed? Can I not take an h out of everything? I can. So what would I have left then?
Negative x minus 1/2 squared.
For those who didn't see that, let me just show you what I'm doing. Okay. Limit as h approaches 0 of negative x minus 1/2 h. Okay. Now, once you get to this point where it's all cleaned up, you are now going to plug it in, just like we did limits last chapter. The first thing we did was, after that was plug it in, right? So then this term right here would go to 0, correct? And you would be left with what? Negative x. This right here, let me repeat what you just found. You found the derivative. You found a formula to find the slope of the tangent. You found the formula right now to find the slope of the tangent. So if I actually want to find what the actual value is for that slope, I have to plug something in here. What am I going to plug in? What point? 2 or negative 2? Which one? 2. So what would my slope of the tangent line then be? Negative 2. Do you all agree to that? Okay. So that is your answer to the first part of the question. The first part of the question said, find the slope of that and write an equation for the tangent line at the point 2, negative 2. Okay. Then you're going to actually write the equation. Do you remember how to write the equation for 2 chapters ago? Point slope. Y minus y1 equals m times x. And I'm just going to leave it in point slope for you because I'm pretty sure you can figure it out. But y minus, or actually plus 2 equals m times x minus 2. That is the equation for the tangent line. That is the slope at the point 2, negative 2. Huge, huge accomplishment. Yes.
What form did you say you needed the equation in?
What did I what?
The equation, what form?
This is point slope form.
Well, but I didn't know.
You're probably going to write it in a slope intercept form, but I'm pretty sure you don't know how to do it. Okay. On a good majority of your homework right now, you're going to do everything like this, and it's a pain. And I know you hate it, and I know you're already like, ugh, no. It's. Can I tell you what I always say every time? And I say this. I've already said this to you. The hardest part of calculus. There's nothing really calculus-y here. The hardest part is you just making sure you distributed correctly and subtracted correctly and simplified. It's algebra, y'all. It's algebra. That's it. The hardest part. All right, we're going to do one more, and it's question number 22, which is actually your homework, and then we're done. D-O-N-E, done. Yay. Number 22. Find the derivative, but you really mean what, Mrs. Setta?
Slope.
Thank you. Of f of x equal to square root of x plus 2. This one's a good doozy. I enjoy this one. All right. What is the first thing that I need to find? I need to find the f of f plus h. Okay. So I substitute into this formula. Everywhere I see an x, I'm going to put an x plus h. So I would actually have the square root of x plus h plus 2. Do you all agree?
I agree.
There's nothing more I can do there. Okay. All right. So now I'm just going to go to my formula for tangent slope derivative. I should actually write f of x right there. Okay. So it would be the limit as h approaches 0 of f of x plus h minus f of x over h. So I would have the limit as h approaches 0 of the square root of x plus h plus 2 minus what? Over h. All right, well, we got a problem. Because if I try to plug in right now, what's going to happen? Can't have 0 on the bottom. That means the limit doesn't exist. So, the D&E, Mr. Setta, does not exist. There can't be a derivative. Wrong. Come on, y'all. Wrong. Mrs. Setta has given you radicals before, and what did you do to them, children?
Rationalize.
You rationalize. Did you rationalize in your limits like you did last chapter? Did ya? You got it on this problem. What am I going to multiply the top and bottom by? The conjugate of this numerator, which would be square root of x plus h plus 2. Sorry, I'm running out of room. What would go in the middle? Plus root x plus 2. Same thing on the bottom. Sorry for how squeezed it looks like. All right, but then I foil the top. I don't really foil, though. I fl. Okay. So what happens to this square root of x plus h plus 2 times another square root of x plus h plus 2?
Gets out of the radical.
Woo! So it becomes x plus h plus 2. And what does this guy become?
Minus x plus
Careful.
Minus x minus 2.
Right. You got to distribute. So it's minus the quantity x plus 2, which means you actually have to distribute. Be very careful. That's what will mess you up tonight. Over h times what, though? Forgot to write this in there. Over h times this, right?
Yeah.
Times the square root of x plus h plus 2 plus... Okay. Sorry, I forgot that. All right, so what will cancel from the top? X's and... Oh, I didn't want to cancel the h. Well, I'm going to in a minute. I can cancel the h with the bottom h. Why is that? Because it's dividing. They're monomials. They're dividing. So what do I actually have on top right now? 1 over this conjugate piece, correct? X plus h plus 2 plus square root of x plus 2. Now, do your first step of limiting, which we learned the first step of rule of limits is to plug it in. If you plug a 0 just where there's an h, not where there's an x, y'all. We're making h small. Just where there's an h, wouldn't this just go to 0? And you would be left with 1 over square root of x plus 2 plus another square root of x plus 2, which really is how many of those? So you write 1 over 2 root x plus 2. What you just found is the derivative. It is a formula to find slope on this at any point. So if I had given you a point like, all right, we'll find the slope now at 2 when x is 2. Or, okay, find the slope when x is 5. You can find the slope right now. You plug it in right here. Find the slope when x is 10. When x is negative 12. Well, actually, it won't work. Negative 12 is going to be undefined. What? What? No way. This was so much fun. Yes, Jack.
So like, we just found like the equation or whatever.
Yeah, sorry. Go ahead.
So like, so all the other ones, like where it's like, right before we plug in, like that's for every point on the line, always?
Yes, every point on this curve.
Yeah.
On this curve right here. That curve. For every point, that's a great point. On every, huge, guys. This is huge. This is why rocket
What do you
ships
mean
go into
by, what do
space.
you mean by curve though?
Square root of x plus 2. What does that look like?
Like this?
Right.
So like, what if it was like x squared?
The parabola x squared? Well, we would find the derivative formula for that.
Is that one curve though? What do you
Yes.
mean by curve?
That is one curve. The derivative is one curve.
Is it like a cubic one?